to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Oh, see, these are like in a different order.
Mm-hmm.
I hate that.
And the third one, yes.
One?
Yes, the distribution of the mean of each sample is normal, since the data have been determined to be normal.
Oh.
That's the one I did too.
Yeah, third one.
Okay. Number 4, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Yeah, and using the independent samples, third one.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
And increase the sample size. Yeah, so the fourth one, obtain the balance of 90 bank customers rather than the 30.
Right.
I have to go back. I wrote down the answers of like all the questions, but I just put like A, B, or C, D, whatever I chose. And now they're like in a different order, so I have to go back and look at what my B answer was, and then see what it is on this one. But that is what I put too.
What number are we on? 5?
That was number 5.
Okay.
Yeah, last one. Yeah, 1, 2.
All right, so next one. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound, and upper bound. Determine the margin of error for this 95% confidence level.
$1.96.
1.96. See, I'm all.
I have a hard time with these margins of errors. I don't know if I have the wrong formula or what, but I get them wrong on every single quiz, and I don't know why. So what is the formula? Is it shoot. I have it like M equals, in one case, the Z with the star.
One star.
What?
Yeah, okay. The formula, just the, yeah.
M equals Z star.
Yeah. The formula should be less than 1.
Right. With a standard deviation over the square root. Is that right? I wonder why I get that wrong every time. Right. Hi, Kelly.
Hi.
Hi.
Sorry I'm late.
Oh, no problem. No problem. Anyway.
I woke up and my clock said 2:59. And, I was like, well, okay, I'm going to be a little bit late. So, I honestly did not get to go through very much of the quiz ahead of time, so.
That's okay.
And when I opened up, of course, the preparation assignment, they said is the same as the quiz. So that's what I actually was working on. And I was a little bit overwhelmed because I felt like they were asking the questions in a different way and I wasn't sure I was understanding them.
I don't like that.
So, okay,
I
anyway,
noticed they do that a lot. Huh.
what number are you working on right now?
We just did number 6. Do you want to go through those first 6 really quick?
If we could, I think those were the only ones I actually answered on my own, was the first 6. If you just want to give me the answers and then I can check them against what I did.
Sure. So number 2 is the second one. We are 90% confident that the true mean heart rate is between 45 and 105.
Okay.
Number 3 is the third one. Yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Okay.
For the third one, confidence interval for the difference of mean using independent samples.
Okay. So far, I'm doing well.
Good. 5 is the last one. Obtain the balance of 90 bank customers rather than 30.
Okay.
And 6, the margin of error is 1.96.
1.96.
See, and it didn't ask us that in the questions.
No, it asked for the confidence
Intervals.
interval, and I could not compute it to equal any of the confidence intervals that it asked.
Oh, I was able to.
You were able to?
Yeah.
How did you do that? So I put it into the inference tool, and I could not get an exact answer.
So let me turn on my thing. I just input it in because you don't have like data, right? For it, you don't have a whole bunch of numbers for it. So I just put in each.
So when I brought up the tool, then I just input the numbers into the the summary statistics type of thing.
Right.
So
yeah, that's what I did. But did you do it on the did you do it on the one sample t-test?
Where did I do it? Right now, yes, one sample t-test. And so I had the mean as 1, standard deviation is 0.01, and
the mean isn't 1, the mean is 1,000.
Sorry, 1,000. I changed some things around to, okay, I did have that when I first put it in. And the standard deviation is 0.01, and then we didn't have an N. Confidence level is 0.95, null hypothesis 0. That doesn't even matter. But when I put
the mean should be 1,000. The standard deviation should be 2.
2. Okay. I must have put another one. I put a different one in there, and N was 4. That's right. Okay. And
then 95% confidence level. And I didn't put anything for the null hypothesis, I don't think.
Yeah, that doesn't matter. Okay, so then the confidence level that I ended up with, or confidence interval, was 996.818 for the lower one, and 1,003.182 for the upper one. And at least on the homework end of it, it didn't have those exact numbers. It had something close to it.
I had 998.04 for the lower bound and 1,001.96 for the upper bound. Is that correct?
Yeah, I think.
Okay, I don't know.
So read those again, because that's not what I've got.
So the lower is 998.04. Is that what you got, John?
Yes.
Okay. And then, so that's actually the answer for number 7. So then the upper is 1,001.96. 6.
96, yes.
I think what
That's
the
the
easy way
answer
to
for number 8.
the best way to do it is take the margin of error and subtract it from the 1,000 and add it from the 1,000.
Oh yeah, you could do it that way too.
Uh-oh, did I
That's
lose
why I
you?
did it.
Okay, but that's assuming you've got the correct margin of error.
Right.
And so when I put all these numbers in, it sounds like I put in the same numbers as you, the 1,000 for the mean, 2 for the standard deviation, 4 for N, and confidence level is 0.95, but it computed the different numbers for me.
It's 4 for the N.
4, right. And confidence level of 0.95. And so but it's computed a different confidence level for me on the thing. So I'm not sure what,
Actually, now that I just put it back in, I got the same thing that you did, 996.818
uh-huh,
and 1003.182.
yeah.
But that's
I
not
thought.
what I got when I did the questions. When I did it when I did it on the, let's see, factory makes propeller drive shafts for ship.
Where's Excel?
I don't know. Now I can't get the right answer. I don't know what I did before.
John, have you already submitted these answers and gotten them right?
Yes, correct. Yeah,
Well, the thing is on the assignment, it has things that you choose from. So
Right.
that's what I got. I got the 998.04 first, so I didn't even like try to do it again. But now I can't duplicate that, which is weird.
Huh. Well,
I'm trying to think of what.
yeah, because I erased it all and put it all in again a couple of times, and it kept coming up with the same thing. And so I kind of frustrated me a little bit.
Yeah, I don't know. I know that's what I did, though. I know that. I remember it's like sitting here and thinking about what am I supposed to do to figure this out. I don't know. Sorry, I don't know how to. How did you do it, John? Or maybe.
See, the margin of error that I got was like 3.182. on that.
Well, but that's.
Which fits with that confidence interval that I got, but, you know.
Well, but if you look at the margin of error formula, it's the 95, it's 1.96 times 2 divided by 2, basically, right? So it's just 1.96.
2 divided by 2.
Right. Yeah, and that's it. Yeah, that's if you compute it that way. He showed us that little trick to do the
Inside the Excel.
in the Excel. And so that's where I got my margin of error from. But So I don't know why it's not computing it in the sheet. I forgot about the other. So, all right. Well, let's go on.
Well, now that's going to bother me because now I don't know if I don't know how I got it. I don't know how I just happened upon. I mean, I must have done it right the first time, but I don't know how I did it.
Well, if you take that margin of error, like you said, and add and subtract, you're going to get the correct answers, but that bothers me that it's not working in Excel.
Oh, trust me, I know the feeling.
Yeah, I just did it in Excel right now, and I got the same one you guys got, the 996 and the 2003. Weird.
We're doing something wrong.
Right.
I don't know what though. Sorry, I don't know.
Excel can't be wrong.
No, it's definitely operator error.
Unless.
Okay, so do we want to go on to 9? Does everybody have 7 and 8 put in?
Yeah.
Yeah.
Okay.
Okay.
Okay, so number 9, you said?
Yeah.
Yes. Question 9.
All right, to assess the accuracy, what?
This is the one that the first numbers I was spouting off, this was the numbers that I had started to put into the
yeah.
sheet, but now I don't trust the Excel tool.
Okay, so to assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean u and standard deviation 0.01 grams. How large should n be so that a 95% confidence interval for u has a margin of error of 0.0001? And I got 38,416.
Yes. 38416. Yeah, is the right answer. Yeah.
I love when my answers match yours, John.
Okay, so then this was kind of stumping me. What did you put this into the tool, or did you?
I just did the sample size formula.
Yeah, I use the formula.
The n equals, and then in parentheses, z times the standard deviation divided by the margin of error, all of that squared.
Oh, yeah. I wrote that.
Divided by what?
So in parentheses is z with the little star, asterisk, whatever it is, times the standard deviation all over the margin of error.
Oh, okay, and solve for n.
And then that's all that is in parentheses, and then it's all that is squared.
Okay. Okay, so I'm sorry, I'm being really slow here. We've got 2 variables here, so how are we figuring out n?
What?
So it's z, we've got n and we've got z. So
z is the confidence level, right? So 95% is 1.960. So it's 1.960 times 0.01 divided by the margin of error, which you want 0.0001. And then that answer squared.
Okay.
Yeah, I got it.
Okay. I'll have to come back to that.
Just remember it's the sample size formula and look back and find that.
Okay.
Yeah, I forgot that Z was that 1.96. Okay, that's what I did wrong.
Well, and this one was confusing me. I didn't even think to do that sample size formula. So I was like, margin of error, 0.001. I was thinking, what the heck? 99% is 0.01. So is that like 99.99% is 0.000? I was way confusing myself. It was way easier than I was making it, which I do to myself often.
Okay.
I know. I find that I overthink things a lot.
Right?
I overthink it, and every time I do that, I get into trouble.
Yep.
I make it harder. All right.
All right.
Do you want more help with that, or are you ready to go on, or what did you want to do?
I'm ready to go on. Yep.
Okay. All right, so number 10.
The mean area mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicions. The appropriate null and alternative hypotheses for mu are what?
The last one?
I would say the last one. Yeah.
Yes, I think so. All right.
I just realized that John left.
Oh, did he?
Oh, we did? Oh.
I don't have my screen up here, but he's not on here anymore.
Did I re-invite him? I'm gonna re-invite him just in case something happened.
Guess that's why he didn't answer me when I asked him if my answer matched his.
Yeah.
Okay. Okay. So she was on here.
All right, so do we want to go on to 11?
Yes,
Yeah.
please.
Okay, in a statistical test of hypotheses, we say we reject the null hypothesis with the level of significance A if the p-value is less.
That's what I.
Right.
The p-value is less than.
All right.
I have two computers that I'm like have the questions that we had to go through on one computer so that I can compare with the answers that I have down, and then I have my laptop like right in front, but I keep using the mouse and it's not working on my laptop. So dumb that you can do the same thing so many times. That's just stupid and wonder why it's not working. Okay, number 12. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variants are nearly equal. Can they use an ANOVA hypothesis test to answer their question? I did yes.
Yes.
The third one?
The third one. Yeah.
Yeah.
So John just texted he lost his internet and he can't get back on.
That stinks.
Yeah.
I hate when that happens. Like, it's all we have is our internet to if that goes, we're done. Anyways, Should I read the next one or?
Sure.
All right. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The research has
Committed to type 1.
Yeah,
That's what I put.
that's what I was saying.
Committed to type 1.
Yeah. Maddie?
Yeah.
Can you hand me the mouse that's sitting over there? Thank you.
Okay, so 14. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? The first one.
Yeah.
I wish our test was multiple choice so you could say, oh, that's not right. Figure out a new way to do it.
Well, some of them were multiple choice last time, weren't they?
Not the ones where you enter in the numbers.
No, but I mean, not all of it was like that, was it? I can't remember. Sorry, my brain's still foggy.
Okay, 15.
The nicotine content in cigarettes of a certain brand is normally distributed with mean and mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X equals 1.5.
Okay, I return back.
Oh, yay.
Oh, good.
Yeah.
Is this evidence? This is number 15, John.
Oh, okay,
Is
number 15.
If this evidence that the mean nicotine content is actually higher than advertised, is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypotheses. Mean, or the null hypothesis, mean equals 1.5, alternate is greater than 1.5.
Mm-hmm.
At the 0.05 significance, you conclude that you should, okay.
So I got a p-value of 0.0403, which would mean we rejected the null hypothesis, right?
Yeah, last one. Yeah. And
Good.
the first time I careless, I missed the question. Yeah, and reject the null hypothesis. First, I chose the first one, reject the alternative hypothesis.
Well, so if you ever are, I mean, this one's an easy one, but if you ever get to something that you don't quite know, you know it's not the second one, and you know it's not the first one because it's not. You can't reject the. You can either fail to reject it, or you can reject it. So there's only 2 of those answers that it could even possibly be, right?
Mm-hmm.
What did you say? What did you say you got for your p-value?
0.0403.
Okay. Okay.
All right. 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure?
Independent sum
Yeah,
for
that's what I got too.
All right. Number 17, an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in the sibling order. Should she use a hypothesis test based on independent or dependent sampling?
dependent sampling.
Independent.
The last
That is
one.
the last one.
Yeah.
Mhm. Let me go on the next one.
Yeah.
Right. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon, milligrams per liters, level of each sample. The measurements are recorded in dissolved organic carbon, Excel. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of 4 types of confidence intervals listed below, which one is appropriate for the situation?
What did I do?
The first one.
Confidence interval. Yeah, that's what I did too.
Yeah, first one.
Is unknown. Yeah.
Yeah.
All right.
All right. Determine, which of the following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound, and upper bound. See, and it didn't ask for the margin of error again in the questions.
Mm.
And the first I get the low bound and the upper bound. Then use the low bound minus the the upper bound minus low bound. Then divided by 2. So the margin is 2.025.
2.025.
Yeah, yes, 2.025.
Okay.
The low bound is 11.168. The upper bound is 15.217.
That's what I got on those two also. 11.1.
Okay, I did that with the tool and it worked just fine. You said the margin of error 2.025?
Uh-huh.
Okay, yeah, it worked for me this time.
What'd you get for the lower bound? Oh, for the upper bound. Number 21.
Upper bound is 15.217.
Thank you.
Okay, a random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded in used Hummers, yada, yada. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles, group 1, and Hummers for sale in New York, group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation?
It's an independent sample, so the third one.
That is what I chose. Yay.
Okay.
Want to do the next one? Calculate the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and New York. Input your answers for the lower bound and upper bound. 23 would be lower bound.
So for the lower bound, I got negative 423.
Hmm?
Is that right?
Yeah, right. Then
Okay.
point 238.
What? What's that?
Yeah, negative 423 point
Okay.
238.
0.23. Oh, see, I don't have a 0.238.
Can you turn off the curtains?
So what is
Wrong
it?
from
Negative 423.28?
0.238.
238. 238.
Sorry. Sweetie, I'm busy right now. I'll come out in a minute, okay? Can you shut that door?
Yeah.
Thank you. All right,
Okay.
so 20.
Hold on. I'm still putting this in to see if I'm getting the same answers as you guys. We're using the independent samples. So the two sample t-test, right?
Yes.
Okay, and our confidence level was 0.95, correct?
Uh-huh.
Okay.
Hmm?
And, all right, so then the lower bound, let me just read this again because I wasn't listening before I was putting this in. Negative 423.238.
Yep.
Yes.
And then the upper bound, 5417.336.
Yeah, correct.
Okay, all right, so I got that. All right, and the upper bound, let me just, 5417.336. Okay, all right.
Okay, many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups: a control with no jumping, a low jump group, and a high jump group. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The data are recorded in that Excel. Researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Use a 0.05 level of significance. What is the correct hypothesis test for this situation? ANOVA.
ANOVA.
And the 26, calculate the test statistics. 7.9.
7.9978.
7.978. Okay.
P-value.
0.002.
Yeah, 0.002.
Or, okay, 7.978. All right. Okay, and you said the p-value
0.002.
0.02. Okay. All right. So question 28, go ahead.
Which of the following best expresses the conclusion of this test? To use a level of significance of 0.05. The second one?
The third one, there's some, yeah,
Third?
okay.
Wait, which one is it?
Yeah, and the third one, there's sufficient evidence to conclude the mean bond density of at least one of the groups are different from others. Yeah, let me see.
Which one did you choose?
Yeah,
There's
I choose 1, 2, 3, 4.
4. Okay.
4.
Yeah, there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different.
Okay.
Okay. These are long. Pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. The data are recorded, blah, blah. Perform a hypothesis test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 0.1. For the next 4 questions, do 14 days minus 90 days for the analysis. What is the correct hypothesis test for this situation?
Dependent sample test, last one. 1, 2, 3, 4.
Yeah,
5.
dependent.
Right.
And these questions in the textbook. Already in the
Remember
textbook.
that one.
Yeah, I did.
Yeah, we've already done this one. All right, so calculate the test statistic. So
1.685.
1.685.
Yeah, 685, correct. P-value 0.096.
That's what I got to. I'm almost done, sweetie. Just a minute, Kate.
Okay, I'm sorry. I'm still trying to catch up here. So
Sorry, we already like went through, put these in, and just have.
I know.
So
I know.
sorry, I don't mean to rush you.
I've worked 7 out of the last 8 days, and so I'm just
gosh.
gonna.
I don't know how you do that. I'm so lucky.
Either. I'm on one more night, and then I've got a 5-day stretch off. So,
Yes.
So you're gonna sleep for 5 days?
I would.
It's tempting. Yes, it is tempting. Okay, so, and we're doing our, say, 14 days minus 90 days. I just want to see if it's different, right? They're not saying one is greater than the other. They just say asking if it's different.
Right. So not equal to.
Okay. All right. So I got that in. So test statistic 1.636. Is that what you guys got?
1.685. Did you do the confidence level at 0.9?
0.9, but I probably need to take out. Let me just take out the ones that didn't have 2 values.
Actually, I got that anyway. I didn't take out the ones that don't have the values. It didn't compute them. That's interesting.
Let me. Okay, now I got 1.685. That. Take the ones out that don't have 2 values for the. Okay, 1.685.
Yes, and then the p-value.
And then the p-value, I got 0.096.
Yep.
Correct.
Okay. So number 32. Which of the following best expresses the conclusion of this test? Use a level of significance of 0.1. So our p-value is
There is sufficient evidence to conclude there is a difference in the
oh, no, our p-value is
second one.
less than. So it's less than, so we reject, which means there's insufficient evidence to conclude that there is a difference. So number 1?
No.
I thought it was number 3.
It's so, you know, with these
Number 2.
ones, I mess myself up because I overthink it and do double negatives and all this kind of stuff. So
I did.
Yes, it's
So-
a double negative. It's very confusing.
So in my notes, I have written down, if p-value is less than a level, we reject the null hypothesis. And then on another set of notes, I have, if you reject the null, we have sufficient evidence to say that the alternate hypothesis is
Right.
So I've put them in so that they're together, because it like they say them in different ways. They like ask you if you reject or don't reject or whatever, fail to reject or reject it, and then they'll ask you if it's sufficient and insufficient, and it was always confusing me, so I just made sure that was in my notes just so that I could keep.
yeah, on the last quiz, those were the 2 questions that I missed on the quiz.
I think I missed those too.
Yeah.
Because
So
I confused myself.
So let me talk through this here. So our p-value is less than our level of significance.
Right.
So we're going to reject the null.
Right.
Right. Okay. So if we're rejecting the null,
Sufficient.
Then
then
there's
we're saying
sufficient
that there
evidence.
is a difference between that
Right.
there
If
is
you're rejecting it, you have to have sufficient evidence to be able to do that.
okay. So there's sufficient evidence to conclude that there is a difference in the mean cost of tickets?
Right, because that's what we're trying to prove, is that there's a difference.
Okay, so then number 2 on here. Sufficient
We're
evidence.
rejecting the original for the alternative,
Number-
right? And then, yeah.
So number 2, there's sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased.
Okay.
Does that make sense?
Yeah,
Is that right? Or am I out in left field?
I don't know. No, I'm confused.
It's either the second or the third one.
Right. So which one is it, John?
Yeah, second one.
Second one.
Okay.
Okay.
And what did we decide on number 26? I didn't catch that, the test statistic.
Okay,
7.
26. Let me see.
I had
7.
7.978.
Okay. I think that's what I got. Let me check. I have all these Excels opened up.
I know.
Yeah.
Yeah, that's what I got. Okay.
Yeah, 26 is 7.978.
Before we submit this, do we want to go back and have John check our work before
I think that's a good idea.
for the ones that he was out for? I don't remember when. Do you remember which ones?
He came back to 15, so it would be like the last, what, number?
Yeah.
I was thinking number
And,
11.
Yeah, we can start from the number 8 because
Okay.
Okay.
I have already checked the number 1 through number 7. We can start from the number 8. Check the
Okay.
number 8.
Isabella?
Let-
Bella.
Let me see. Okay. You could number 8 and the question 8 and 9 we already checked. Then okay. Then question 9 is 38416.
Wait, which one are we on?
38. Yeah, question 9.
Question
9.
9.
This one, the other one.
Yeah.
38416. I think Tessa already get the right answer.
Yeah, that is what I got.
Yeah. And then question 10. Question 10 is the last one.
Okay.
We chose question 11. Question 11. The p-value is less than alpha. It's the second one.
Okay.
Question 12. Question 12 is 1, 2, 3. Third one. Yes, it's enough. That is the data of each apartment building are bio-shipped with no outside. Yeah, it's the third one.
Okay.
Question 13. Question 13, the answer is committed type 1 error. The first one. Question 14. Question 14 is number 1. I reduce the probability of commit type 1 error. We increase the probability of the committing the type 2 error. The first one. Okay. I think you already get all the right answer.
Okay. Perfect.
Yeah.
Thanks, John.
Yeah, no problem. I will go to work. Yeah, I have already been late. I will be late for over 20 minutes. Okay.
Thanks,
Bye,
John.
John. Thank
Okay,
you.
see you.
Thank you.
Yeah,
Bye.
good luck. Good
Thanks.
luck for your exam.
You too, John.
You want to submit?
All right. Yeah, I got 100. So
I got 100.
Yep.
Okay.
all right. Well, my computer's about to die, and my son can't find the charger.
Uh-oh. Okay.
So I'm glad we're done, and good luck, everybody.
Look.
All right.
Oh, wait a minute. I missed
So Monday at 3?
Monday at
Monday.
3.
Okay, perfect.
See y'all then.
Thank you.
Thanks. Bye.
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 Thank you.